Last time you looked at probability distribution table, and today we're going to be looking at conditional probability distribution tables. So to get the probability distribution tables, you basically divide each of the frequencies by the grand total to get the probability. All right, so last time you've looked at the gender and the position. We had teachers and students. Oops, that's a terrible line. Male and female. And we had the totals this way. And we got the frequencies or the probabilities of each of these. So for male teachers, actually let me start with the frequencies first. So male teachers, there were 4 male teachers and 6 female teachers. There were 24, I believe, and 26. And the total for the teachers, there were 10 total teachers, 50 total students, 28 total males, 32 total females, and the grand total was 60. And what we did to get the probability of each of these was we divided each of them by 60. Today we're looking at the conditional probability distribution. What do we mean by conditional? So instead of looking at the percentage of the whole, so if we convert this to the probability distribution table, let me just do the calculations very quickly. So we will get 0.07 over here, 0.1 over here, 0.4 over here, and 0.43 over here. So this tells us the percentage of, for example, male teachers in relation to the whole population of the school. But sometimes you would like to know what's the percentage of males if we're just looking at the teachers. So in other words, if we're just looking at this part right here, what percent is male and what percent is female? Or you might ask the same question with students. What percent of the student body is male and what percent of the student body is female? Notice that what we have here doesn't answer that question. This just tells us that 40% of the whole population, including the teachers, is male students, and 43% of the whole population is female students. This doesn't mean that 40% of students are males and 43% of students are females. So we can categorize these differently. So we can just look at each of these rows separately instead of calculating the probability like this. So there are 2 ways to do conditional probability distributions. You can look at the rows like this, or you can look at the columns. So I'm going to do the ways with rows first, and then I'll do the ones with columns. So to do with rows, what you do is, instead of dividing the frequency with the grand total, you divide the frequency with the marginal frequency here. Okay, so because we're looking at this row right here, we are just dividing this data with the total of that row only. So we're doing 4 divided by 10 instead of 4 divided by 60, in which case it'll give us 0.4, and for female teachers, we're doing 6 divided by 10, right? So we're going to get 0.6. So what does this mean? This means that just looking at this row, or just looking at the teachers, 40% of them are male and 60% of them are female. And of course, if you add these two, you have to get 1. Right? Because this is all of the teachers. And we can do the same thing for students. We can do 24 divided by, instead of doing divided by 60, we're doing 24 divided by 50. Okay? In which case we're going to get 0.48. And for females, we're going to be doing 26 divided by 50, in which we're going to be getting 52. And again, if you add those two, you have to get 1. So what does this data tell you? If we're just looking at this row, the students, if we're just looking at students, it means 48% of them are male and 52% of them are female. Okay, notice this tells us a different kind of information than our probability distribution table that we had before this table. Right? We are looking at each row separately here. We're looking at the teachers, what percent of teachers are male, what percent of teachers are female, and then we're looking at students, what percent of students are male, what percent of students are female. Now we can do the same thing by looking at the columns instead of the rows. Let me write that down here then. Oops. So I need more space. That. Right, so I have male, female, teachers, students, and then total. So now we're looking at the columns. So what will the columns tell us? Oops, let me use a different color. So this first column here will tell us if we're just looking at males, what percent of them are teachers and what percent of them are students. And similarly, if we're just looking at females, what percent of them are teachers, what percent of them are students. Okay, so again, this time we're taking each column separately. And let's calculate the probability. So this time, instead of dividing by 10 for this one, we are dividing by this total here, the total down here, since we're looking at the column of males. So we're doing 4 divided by 28. 4 divided by 28, you're going to get about 0.14. And for students, we're doing 24 divided by 28. You're going to get about 0.86. For the female part, we're going to be doing 6 divided by 32. We're looking at this number right here. So about 0.19. And then 26 divided by 32 is going to be 0.81. And again, if you add these up like this, you have to get 1. And what do these tell you? Though this tells you that 14% of male, we're just looking at the male, 14% of male are teachers, and 86% of male are students. And here, 19% of females are teachers, and 81% of females are students. So I hope that these two conditional frequency or conditional probability distribution tables make sense in that what kind of information they're showing and how it is different from this data right here. All right, that's not actually different, but it shows a different kind of data. So, for example, if I were to ask you, given that someone, let me write down the question here. Given that, given that someone is a male, what is the probability that he is a teacher? Then which probability distribution table should you be looking at? It's given that someone is a male. So we're looking at males, right? So that means we have to look for something where they group the males together. Okay, so that would be this red section right here. Given that someone is a male, what is the probability that he's a teacher? And the probability for being a teacher is 0.14. Right? What if I were to ask you, given that someone is a student, what is the probability that he or she, or let me just keep the he here and say that he is a male. Right. Or actually, I might have to still say he or she, yeah. Okay, so given that someone is a student, what is the probability that he or she is a male? I have to look at the part where they group the students together, right? So because it's given that they are students. So that means I have to look at this yellow section right here. Given that someone is a student, the probability that he or she is a male is 48 or 0.48, 48%. And if I don't have any given, and I just ask you, what is the probability that someone is a teacher? Okay, I haven't assumed anything here, right? I haven't assumed anything. This means I can't look at any of these individual components. I have to look at the whole thing, right? So that means I need the probability distribution table, not the conditional. So I can't use these tables for this one. Remember on the last lesson we had, where we divide each of these by the grand total, the 60. I believe probability was 0.07, 0.1, 0.4, and 0.43. And these would be 0.17, 0.83, 0.47, and 0.53. If you're wondering how I'm getting this probability here, you can look at my previous video. But this would be the table that I need to answer this question, because I'm not assuming anything, which means I have to look at the whole thing. What is the probability that someone is a teacher? In which case, I have to look at this total right here, because again, it doesn't say male teacher or female teacher, it just says teacher, so I have to look at the whole thing, and that would be 17.17. Okay, so using these kind of probability distribution tables, I hope it made sense. You should be able to solve or answer probability questions. Questions like these are actually quite common in SATs and other standardized tests. So being familiar with probability distribution tables is very important.